Okay. Saya tak bagi lagi contoh kan of some basis. So I will go through that exercise, yeah. Okay. Before that, we recap. Okay, recap. For Rn, the dimension is n. So you have to have n number of vectors in the set S to be a basis. Like if you have R ni tak nampak sangat satu kan. R2 you have to have 2. R3 you have to have 3. If not, it won't be a basis. I did not say that if you have 3 it is a basis. Tidak ya. It's just one way. If it is a basis, it has to have 3. Ada beza kan? Okay. If it is a basis, it has to have 3 for R3. I didn't say if there is a 3 vector in S, it is a basis. Tidak. Yang itu tak betul. Okay. It can be 3, but it might not span. It can be 3, but it might not be independent. Mungkin dia ada yang multiple combination, dia jadi not independent. Dia mungkin 1, 1, 2, 2, 3, 3 macam tu kan? No. 1, 1, 1, 2, 2, 2, 3, 3, 3. So they all at the same line. Cannot span the whole thing. Okay, so itulah dia punya basic dia. Nak tahu ya atau tidak. If you have like P3, then it has to have 4. N plus 1, yeah? Because the basis is 1, x squared, right? So 3. If it's P2, 1x squared. That's why it's plus 1. For the matrix, it has to be m times n. Okay? We don't do for function. Okay, now for the first question, S is 1, 1, 2, 2, 1, 3. Okay, now Rabiatul Adawiyah. What is the vector space? Rabiatul ada kat sini tak?
Ada, Prof.
What is the vector space?
M multiply N.
Mana M pula? Dia nampak macam matrix ke? Apa? Mana satu? What's the vector space?
3.
Apa yang 3?
3 vector space.
Yelah, apa? Apa vector space this one? Is it R? Is it P? Is it M?
R.
R3. Soalan dia. Okay? Because there are 3 component. R3. Although you have only 2 vectors. Yeah? U1, U2. Okay? So we call it U1, U2, R3. So the rule is you have ganggu betul lah Nabil ni. Tutup lah. Dia macam gelak-gelak ke saya pula. Okay. It has to have 3 to be a basis. If it is less, it won't span. Ingat theorem yang kita tengok itu. If it is less, it won't span. So if S is U1, U2, Um. Okay? And the dimension of V is N. This is the dimension, yeah? So if M is less than N, does not span. I'm giving you a shortcut to the answer. You don't have to prove if it's already true. Okay, then you're just wasting your time. If it is not a basis, just show why. Just pick the one that it is not. If M is bigger than N, not linearly independent. Okay? If M is N, then you have to show accordingly using definition. But the methods can be different. Yeah? You mentioned it has to span, write out the definition. It has linearly independent, write out the definition, because it all give you marks. And how you solve that is using chapter 2. Whether you can show it's consistent with the method of determinant or the rank, or you solve the equation. Okay, so this is a very basic thing that you should know. Just by looking at the question, you will know whether it is a basis or not. All right, so for this one, M is 2, right? 1, 2, N is 3. So 2 is less than 3. For sure, it does not span. Okay, so you know this is not a basis in the first place. Don't just go right ahead and just write out. Just think first. Okay. Okay tak ni? Clear tak? Cuba bagi jempol sikit. Ibu Jari. Clear, ya? This one is clear. Okay, for the basis. It's not hard at all. Whether the number is enough or not. If the number is enough, still, you have two choices. You can do the determinant, right? Yes. Okay. Because when the determinant is not 0, and M is N, then we know exactly that it has a unique solution, right? From chapter 2. I'm not saying about whether there is a solution or not, because in chapter 2, don't get confused, because determinant is 0 can give many solutions, right? Can give many solutions, which is consistent, but we want it to be independent. Independent means unique solution. Cannot have many solutions for the homogeneous. So that is why we just do determinant and then okay. Okay, I will show you one which is less, one which is more, one which is equal. Nak padam ni kalau okay. Right. Okay, so we claim S is not a basis since it does not span R. Because to be a basis, it has to span V. What does it mean by span V? For all V in V that exists C1, C2, C3 until Cm in R, such that any vector Y in V can be written as a linear combination of vectors in S. So that exists C1, C2, Cm until R, such that Y is C1, U1 plus C2, U2 until Cn, Un. Okay, that is the spanning. Spanning means any vector in V can be written as a linear combination as vectors in S. Which means you can find the C's, right? Okay, it goes back to the one before. That is what it means by spanning on. And it has to be linearly independent. What does it mean by linearly independent? If you have C1 U1 plus C2 U2 plus CM UM equal 0. You have to put equal 0. Then all CIs has to be 0. It's a little bit different than spanning. Yeah, spanning is you write in terms of general Y. But for the linearly independent, you replace Y with the vector 0 and try to see whether the C's are unique, which is all 0, or many. Okay, because homogeneous, you only have two kind of solution, unique or many. If it's unique, independent. If it's many, dependent. All right, that's the basic things that you should know. Okay, so how do I show this? It's by showing that you cannot solve the system. Okay, so this means let Y, X, Y, Z in R3. This is also very critical to know what V is. If you don't know what V is, you cannot put Y equals what and solve in general. Okay, so find, there's only two, right? C1, C2 in R. Okay, such that Y is C1U1 plus C2U2. There is a mark for this. This shows that you understand what it means by spanning. So you take any general Y in R3, you want to find if there exists the C's. Why there are only two? Because there are only two vectors. Okay, in R such that this Y is equal C1 U1 plus C2 U2. So even if I change the question to 3 to 4 to 1, you just change accordingly. So you understand this is the basic thing that you should write in all questions. Yeah. Okay, just solve this. So you will write C1 112 plus C2 213 equal X, Y, Z. Okay. I erase the question, yeah? Not enough space. Okay. So as before, we can multiply, add, and equate, but we can write in terms of matrix. If you still remember. So I write in terms of matrix 1, 1, 2, 2, 1, 3, X, Y, Z. I give you 2 to 3 minutes to do the row operation. Okay, so negative row 1 plus row 2, negative row 1 plus row 3. Zero, negative 1, negative X plus Y. 0, -2 plus, -4 plus, -2 plus. For this part, until the end, until chapter 4, you have to be able to do row operation with variables at the end. Okay? Because these variables at the end can be part of your answer. If I ask you what is the spanning set, right? You equal that to 0, remember? But in this case, we just want to see and show whether the C exists or not. Okay? So one more, yeah? We need to make this one to make it easy. Okay, you have to do it in 2 steps. Make it 1 first, then make it 0. Cannot do it at the same time, yeah? This claim is our conclusion later. So just multiply by negative. Okay, until we do echelon form is okay. No need to do row reduce. Saya lupa letak 2. Kat mana? Lupa letak 2 dekat mana? Cubalah bercakap. Ayo.
Tu doktor dekat yang mula-mula.
Yang mana?
Yang first part tu.
First part tu.
Bising
Negatif
lah,
row
ada
1
orang
campur row
rumput-rumput. Apa dia?
3. Yang negatif row 1 campur row 3. It's supposed to be -2 plus.
Which one? This one is
Itu.
This one is okay?
Uh,
Which step? So negative row 1 plus row 2. 1 to x.
Isn't it supposed to be negative row 1 plus row 3?
X plus y. Okay. Negative row 1 plus row 3. Negative 2 row 1 plus row 3.
tu dah maksud saya tadi.
Okay. Okay, so negative 2 row 1 plus row 3. Jangan cakap roti pula pagi ni belum makan. Negative 2 row 1 plus row 3. Negative 4 plus 3 negative 1. Negative 2x plus z. Oh, ni yang betul. Ini yang salah. Dia cakap tapi tak tulis. Okay. So yang lain semua betul lah. Okay. Now, so 0, 0. So x minus 2x minus x. X minus 2x and negative y. Oh, tak muat. 0, 0. X minus 2x is minus x. Minus y. Because this is add, right? X minus 2x is minus x minus y plus z. Okay. So from here, you can see that this is inconsistent, right? Because there is a 0 and then there is this. So you can use chapter 2 to say that the rank of A is 2, but the rank of AB is 3. Okay. Thus, the system is inconsistent. This is optional. This is optional. If you don't write this, but you write the one next, it's still okay. What does it mean? There is no solution. What does it mean by there is no solution? That the C1, C2 do not exist, right? When C1, C2 do not exist, so this means that S does not span R3. Okay, so what does it mean when S does not span R3? So that means that thus, therefore, S is not a basis of V. So you don't need to show linearly independent because myself, I don't know what to put. This is actually linearly independent because there are only two vectors and they are not multiple of each other, right? This and this, there are only two vectors and they are not multiple of each other. So they are actually linearly independent. So if you show linearly independent and the answer is yes, it doesn't say it's a basis. It's just wasting your time. So to show it is not a basis, find something wrong with it. Using dah padam tadi kan, the M bigger or less, okay? And this part, can you hear the sound? Dengar tak? Oh tak eh. This one, if you don't write this as the rank, but you put 0 equal, okay, it's impossible. And then you put equal to over here without saying this. It is okay, full mark. Okay, as long as you tell me that there is no solution. But then you have to relate why it is not a basis. Okay, so step by step. Okay. Clear, yeah? So I can change the question into polynomial. I can change the question into matrices. The work is still the same, except for when you write in terms of the equation, it is in terms of polynomial or matrices. But the matrix will be like this too, right? Because we can put polynomial matrices. So let's see if there's a question like that. Number 9. Number 9 for polynomial. I can erase this. Okay.
Prof, nak tanya boleh?
Ya. Ada soalan?
Dekat apa? Jawapan dekat buku tu dia tulis basis. So maksudnya salah ke macam mana?
Apa dia?
Dekat buku tu dia tulis jawapan dia basis.
Nombor 1. Oh, tu yang you all confused here. Silap lah tu typo. Sorry about the mistake. Nanti kita betulkan No wonder ada soalan Okay, tak apa. It's not a basis It's not a basis. Okay. Number apa tadi? 9. Number 9. Alamak. Okay, number 9. S equal 2 plus X 1 minus X. P is P. Ni pun typo juga. Dah betulkan berkali-kali pun masih ada nampak typo. Is P1. It's P1 because X to the 1. Okay. P2 has to have X squared. So yang ni cukup lah. Yang ni cukup. This one is a basis. Number 9. I'm looking for something which is not right. Yang serupa dengan ni. Untuk P. Tak ada nampaknya. But I'll create another question. Okay. I'll create another question with P2. And then I put here square. Sama ada ini tertinggal ataupun ni typo. Actually for number 9. Kita tengok the original. Let's change this one. So this one is okay, This one is okay. Let's change this one. So it matches with number 1. Okay. Okay, now the dimension is 3. Right? The dimension is 3. How do we know this is 2? Because the highest degree of the polynomial is 2. Because the degree of the polynomial, Pn, this is the degree of the polynomial, the highest power of the variable x ke, t ke. So when you see that the highest power is 2, that is why it's P2. But the dimension is +1. Okay, so you need actually 3. You need actually 3 to be able to be in the spanning. But this is only 2. So you know the claim is it does not span. Okay, so it is not a basis. Okay, so show S does not span. Then you ask, if I don't know the answer, how can I write this? It's okay. You just think it in your head and then you know it does not span and try to write out the definition and show that C does not exist. Then you say it does not span. It is okay. But if you know already the claim is like this or given in the question, write it. Oh, yeah? Okay. S span V or P2 if there exists C1, C2, because two of them in R such that, what is the Y? What is the Y? This is another problem. For all Y, right? For all Y in P2. The the, let me do A, B, C. A plus bx plus cx squared. You have to know in R2, y will be equal to xy. I don't want to write simply. V lah, V, because y that y. Okay, in R3, the V will be x, y, z. Right? The for all. Polynomial, after this, you go through the notes and you see how I can get this y as this. For polynomial, P1, it will be A plus bx. For P2, A plus bx plus cx squared. And so on. Okay, that is your y or your v. Because if you fail to write this, then you cannot transfer into a matrix and solve. If the question give you in terms of t, janganlah pula, alamak, Proniza tak ada ajar pun ada t, it's just the variable. You can change the x to t, but the coefficient is the one that we will see. Yeah, you remember when we transfer into matrix, we put the variable at the end, and then we put only the coefficient inside the matrix, because we comparing the coefficient left and right in the equation. Yeah, so this is actually similar to R. Okay, so that is why I get this, such that y equal C1 2 plus x plus C2 1 minus x. Okay. Then again, we can multiply and then we add and then we equate, right? So you will get 2C1 plus C2 equals A, right? 2C1 plus C2 equals A. Then you compare the x. C1 equals B. Then you compare the x squared. Negative C2 equals C. Okay. So, but if we've seen this before, if you can write this as 1x squared, I still remember I do this in the last class. Put the variable here and then put the coefficient, yeah? So 2 plus x is 2 plus x. 1 minus x squared is 1. Right? And then A, B, C. Okay, this is there is a C1 and there's a C2. And like I read just now, right? 2C1 plus C2 is A. X, yeah? C1 equals B. And x squared, negative C2 equals C. All right? So you see, probably you will say, oh, C2 is negative C. C1 is B. So there is a solution. Unique. But you have to do these two. You cannot just solve these two. That is why we call it a linear equation. It has to satisfy all equations. Okay, you cannot just, okay, look at this. It's unique. I already got the answer. C1 is B, C2 is negative C. No, you have to show that this is inconsistent, actually. Okay. So I will swap to make it this one, yeah? Instead of multiply by 1/2, then you get fraction. You can row 1. I think you can finish this up, yeah? Okay, and then show this is no solution. Adam soalan? Well, I didn't have to do this. Okay, probably you are thinking why I change this one B first, this one I change B here because I want it to be A, B, C. Okay, you want to start with B, you want to start with C. Okay, tak tolak markah lah. Okay, so this means the system is inconsistent. Copy ayat tadi kan. The system is inconsistent. So C1, C2 do not exist. Thus S does not span V. So S is not a basis of V. Oh, ayat dia sama. Okay. But tadi saya termiss nak tanya, what is actually span S? Kalau ada soalan tambahan. Tadi apa dia punya ujung dia? Span, soalan yang tadi span S. Tadi XYZ kan ya? XYZ. So you will write your Y, XYZ in R3 such that, tolong bacakan saya, kena panggil ni, Nurin Anisha. Can you please read soalan yang nombor 1 tadi? In the last part, apa yang dapat tadi? Equalkan 0. Cakap kuat sikit sebab sangat bising kat sini. Yang tadi tu. Kan ada. Ni saya nak ni. Apa yang XYZ dia?
Negative X, negative Y, plus Z.
Yang ni yang kat ujung
Yeah.
Okay. You equal this to 0. This is actually span S. So S actually span a plane. Ni plane kan? Kita belajar dimension 3 dimension. This is a plane. So actually S, sebab dia ada 2 vector, when all the linear combination is 2 vectors, it becomes a plane. A plane macam kertas lah dekat dalam bilik ni. So there is a spanning in terms of plane with this equation. That is actually span S. So how do I know how to write this? Because this is your vector space. Ni yang nombor 1 For this part is different. For this part, the span S is A plus BX plus CX squared in P2, because that is your V just now kan, atau Y, such that ni A minus 2B plus C is 0. Soalan ujian 2 ni. Soalan bocor pula. If you are asked what is span S, so what you should do is if it is consistent, if it spans V, okay, if S spans V, sebab kalau ada consistent, ada jawapan dan sebagainya, your answer will be span S is V. That is, it spans V. It spans. So if S spans V, then span S is actually the whole vector space. All right. If it does not span V, then it span maybe just a subspace of V. If you have this vector space V, like R3, right? R3 or R2 or R3, and you have the set S inside a subset of R3, like just now, then you have U1, U2, just two vectors, not enough, right? To span the whole of V, then it will span just this part. It will span bigger because it's a linear combination, but the set is two vectors, right? If you draw, the set may be just this vector. But the span probably plane, yeah? But your whole V is the 3-dimension, this like this room. If you have 3 vectors in which the angle is different, or the determinant of these 3 vectors, if you count, is not 0, meaning if you solve this, you will get it to be consistent or unique, then you will get this. Then you will get this, meaning you have R3, and then you have S with U1, U2, U3. They might not span, yeah, because if they are multiple of each other or the linear combination of each other, they won't be linearly independent and they won't span because they're probably in the same line or the same plane. But suppose they are all different vectors. So span S will be equal to V, which is R3, and this is equal to span S. So you don't have one in the middle, okay? If it span the whole vector, you don't have the one in the middle. The span of this is the whole of the vector space. Like this one, you have 1, 2, 3. Linear combination of these 3 vectors give you the whole. Any vectors in R3 can be written as the linear combination of these 3. So this is what it means by spanning. Okay. Macam faham sikit. Okay. Nanti dapat soalan. Okay. But it's okay. I think you can get the idea, yeah? Okay. Alright. Pasal span aja ceritanya. Because I want to show you yang it does not span. For this one and this one. So let's try to find one for the matrix. Number 14. Number 14. Kita sebenarnya dah ketinggalan kelas kan because of visa. But it's okay. So this week I will finish until the session we should finish. because after this basis, the graph of difficulty will go down a little bit. This is the top difficult part of the whole semester. That's why I really want you to understand and do it. Okay. 1 0 0 0 1 1 1 1 in M2 post. Okay. Test 1 tak habis tanda lagi. If you are wondering, nanti I will let you know once it's done. Right. Sama je. Less, right? You need to have 4. M times N. You need to have 4 at least to spend. Not to spend, but to spend. Sama kan bunyi dia. You need at least 4 to spend. So you know it does not spend, right? Claim S does not spend M2 by 2, which is the B. So it is not a basis. All right. So find C1, C2 in R, because we have 2 of them, such that for all Y. What is your Y? It's A, B, C, D. Okay, in M2 by 2. C1 times 1000 plus C2 1111 equal A, B, C. For spending, there is no numbers at the end because it's for all Y. So you have to write in general. Okay. Sekejap lagi kita break ya. Sekejap je dah 9:30. Okay, so you can multiply out, multiply, add, equate, right? Multiply, add, equate, you will get C1 plus C2 equals A. Ambil dah, itu je. Yang lain terus dapat C2 is B, C2 is C, C2 is D, right? If you don't want to get confused, like Dr. Mo mentioned in her class, you put K. If you confuse with the C, but this C is for any number C, right? In the real, this is our coefficient. Okay, if you do like this, I do by row, yeah? But it doesn't matter because it's the same, by row or by column. It matters here. So A, B, C, D. Even if you put A, C, B, D, it's the same in this case. Okay. Then you do 1, which is, this is okay. You will have, this is okay. Then you have negative row 2 plus row 3, negative row 2 plus row 4, 0, 0, negative B plus C, 0, 0, negative B plus D. Then when you are here, inconsistent, right? The system is inconsistent. C1, C2 do not exist. S does not spend. V, S is not a basis. Okay, if the question decide whether it is a basis or not, when you say S is not a basis, there is a mark. Okay, don't forget to answer. If the question show that it does not spend or show it's not a basis, it's good to write the conclusion is not a basis, but you might not get that. If you miss that one, the mark may be until it does not span. But to be safe, just write out everything, explain everything. Okay. This is tricky. How do you write the span? How do you write the span of S? If you are asked. Yeah. So, padam na pula. Okay. Okay, span of S is equal to what to write? It's your vector. And what is the vector in your vector space? It's A, B, C, D in M2 by 2 such that there are two. So you can solve this first. Okay, instead of writing both, you solve that first. So you will solve it like this. Negative B plus C is 0. Negative B plus D is 0. What does it mean? Macam mana nak solve ni? This gives B is negative C. This gives B is this gives B is C. This gives B is D. So B is C is D. Instead of putting this together. Okay. And how do you write your answer? You can write this. B is C is D. Ada yang ya? Or if you leave it like this, it's okay. Full mark. If you want to really see, because later on I want to know what is the vectors that span, the basis vector for the spanning. Okay, you will write A, nothing happened to A, but B, C, D, they are the same, right? B equals C equals D. A, B, real number. And actually, if you put, this is actually just multiplying A and B with, when you add this, that 2, right? A, and then these two are equal. So you can see when you take out A, you get 1, 0, 0, 0. When you take out B, you get actually not whatever, 1, 1, 1. So this is the spanning. But this question wants to see whether it's a basis. I just go ahead and write out the span. So I have covered the not spanning part of 1, 2, 3. I have not covered the M bigger than N, but I will go over it after we take a 10-minute break. Lepas 5-minute break je lah Sebab lepas tu habis pukul 10 pun. 5-minute break. So I will share, stop recording. I will share again, siapa yang tak sempat. This will cover the whole section about spanning, linearly independent, and at the end a basis. Okay. And I will try to choose one each. M bigger than N. M bigger than N. Which one? Last one. Last one. S is 1, 1, 1, 2, 2, 2 in. Why is it 2? Why is it 2? Because, why is it 2? Because there are 2 components here for each of the vector. So this is 2. And in this case, M is 3 because there are 3 of them. Okay, M is 3, N is 2. So M is bigger than N, so we know it is not linearly independent. Clear. S is not linearly independent, thus it is not a basis. Okay, so far? Okay. How do you show it is not linearly independent? Write out the definition. Okay. S is linearly independent if you have C1, C2, C3, 1, 2, 3 in R, then C1, 1, 1 plus C2, 1, 2 plus C3, 2, 2 equal, okay, C1, C2, C3 because there are 3 of them. C1, 1, 1, C2, 1, 2, C3, 2, 2 equal the 0 vector. This is what is different from spanning. The 0 vector in R2. What is the 0 vector in R2? 0, 0. So this is the one that will change accordingly to the vector space. If it's R3, you will put 0, 0, 0. If it's P2, you will put 0 because the 0 vector for polynomial is just 0. P1, P2, P3, they're all just 0. Matrix? 0 matrix, depending on the dimension. Okay, so when you get a question, the very first thing you have to see is what is the vector space. And next is, what does it want? How many? Think first, then you have to know the definition. Yeah? Okay. Solving is not hard because this is chapter 2. Okay, but to try to start and how to start out. All right, so again, multiply, add, equate, right? You will get C1 plus C2 plus 2C3 equals 0. C1 plus 2C2 plus 2C3 equals 0. And then you write out in terms of matrix, you will get 1, 1, 2, 2, 2, 0, 0. Lepas ni ada kelas tak pukul 10? Kalau saya terlebih 5 minit. Ada tak? Tak ada. Saya tak akan lebih lah kalau. Okay. Just one row operation, ya. Okay. Remember, there is a C1 here, C2 here, C3 here. Because there are 3 of them. Okay. So you will get 1, 1, 2, 0, 0. Ya ke 0? Suka je. 0, 1, 0, 0. You know, this second case of linearly independent is much, much easier than the first one. Because it is all equal to 0, right? This is always 0. Jangan terkeluar nombor pula lepas ni. Whatever you do with row operation, it will be always 0. Homogeneous, go back to chapter 2, and the answer must be unique or many solution. There is no such thing as no solution. Okay. So this is C1, this is C2. What happened to C3? Yeah, Eugene, what's your question?
You mentioned the definition of linear independent, right? You
Yes.
need to say that C1, C2, C3 is
Yes.
0 only.
Imply C1 equals C2 equal C3 equal 0. Okay, ayat tak habis. Thank you, Eugene. S is linearly independent if C1, C2, C3 in R, then this equals 0 imply C1 equals C2 equals C3 equal 0. So this means the solution is unique. Solution for homogeneous system, homogeneous means this. Okay, because it's equal to 0. Unique means trivial solution. Trivial solution means all equal to 0. Okay, this is what I said before in chapter 2. So for homogeneous system, unique means trivial, which means all equal to 0. So if there is a free variable, means it's many, means it's not unique, means it's not linearly independent. Do you realize I always said about linearly independent and I didn't say, why you don't say linearly dependent, right? Because the basis is if it is linearly independent. So if you answer, it is not a basis because it is linearly dependent, I might deduct 1 mark. You didn't say linearly independent. You just say it is dependent. It's crazy, I know. But because the definition is saying it has to be linearly independent. So you have to say S is not linearly independent. Thus, it is not a basis. Okay, there might be another question. Decide whether S is linearly independent or linearly dependent. Then in that case, you can say, janganlah sampai takut pula nak cakap linearly dependent kan. It depends on the question. Yeah. And it depends on my mood. Maybe if you put dependent, okay, it's okay. Tutup mata bagi markah. All right. So in this case, there is a free variable, right? There is no C3. Not enough for the C3. C3 is free. C3 is free. What does it mean by if there is a free variable? Thus, there are many solutions. There are many solutions means not all C1, C2, C3 equal 0. I'm trying to say the opposite of this, right? Many solutions. So what does it mean by many solutions? It means not all C1, C2, C3 equal to 0. There might be other numbers, which is a solution. Okay? So S is not linearly independent. Thus, S is not a basis. Okay, so your job, if you haven't finished all or you have done it but not the right way, you have to try and find for P and for M. Yeah, for M it's quite hard to get a simple question because the smallest M will be like 2 by 2 and you would need more than 4, which is 5, right? So it's quite long. I don't have any 5 matrix. You can create your own, create your own question. For P2, maybe you find P2 P2 or P1 that has 3. Yeah, P1 that has 3 vectors. Okay, I'll skip those. Maybe it is there in the exercise, but I will go to the last part, which is when it is equal. Yeah, when it is equal. Let me put it. So equal, one example for yes, it is a basis. Equal mean m equals n. Another one is yes, it is equal, but it is not a basis. Okay. Let me see. Number 2. S equal 1, 1, 1, 1, 2, 1, 2, 0, 0. So this is R3, yeah? And we do have 3. Okay. Okay. So number 1. S spans V if for all V equals X, Y, Z in R3. That is C1, C2, C3 R such that C1, 1, 1, 1 plus C2, 1, 2, 1 plus C3, 2, 0, 0 equal X, Y, Z. Then this gives 1, 1, 1, 1, 2, 1, 2, 0, 0, X, Y, Z. Laju. Right? C1 plus C2 plus 2C3 equals X. I actually get this one. C1 plus C2 equals Y. I get this one. C1 plus C2 equals Z. I get this one. Okay. Then you want to solve this. A is 1, 1, 1, 1, 2, 1, 2, 0, 0. You can do one of the 4 methods to solve the equation if the determinant is 0, right? Not 0. Okay? Not 0. So determinant of A, if you take this, easy, right? Because it's the third column. This. Positive, negative, positive. Alamak, dah terlupa lah chapter 1. Macam mana nak cari determinant ni? You go positive, negative, positive 2 and then potong kan? Then 1, 2, 1, 1. So 2 times 1 minus 2, which is negative 2, which is not 0. Okay? So by Cramer's rule or by the theorem in chapter 2, okay, the system has a unique solution. Okay, the system has a unique solution because the determinant is not 0. Then C1, C2, C3 exists. You don't even need to know what is C1 in terms of X, what is C2, because you are not asked that. You just need to show its spans. Okay, unless they want you to write, they tu saya lah, X, Y, Z in terms of C1, C2, C3 in terms of X, Y, Z. Can you write X, Y, Z in a linear combination of these 3? Baca soalan ya. If in that case, you need to write C1 in terms of X, Y, Z, C2 in terms of X, Y, Z, C3 in terms of X, Y, Z, meaning you have to solve this equation using row reduced echelon method, Cauchy-Jordan. Yeah, but this one just need to know whether it is a basis or not, whether it spans or not. So you stop here. So S spans V. Meaning span S is the whole R3. Okay? So we are done with this. But you're not done yet with the second part. Okay? The second part is linearly independent. But for the case M equals N, once you show it spans, automatically actually the determinant is not 0. It is also linearly independent, but you cannot just say, okay, you have to write out the definition anyway. So number 2, S is linearly independent if C1 111 plus C2 121 plus C3 200 equals 000 implies C1 equals C2 equals C3 equal 0. So you don't have to rewrite everything all over again. You just see that this is the same as this, right? With X, Y, Z replaced by 0, 0, 0. Okay, so you put from 1, copy, jangan padam, copy. Saya boleh padam. Senang je, ambil je matrix tu. From 1, make this matrix. Okay, and this again with the determinant, the same determinant, because it's the same A, which is not 0. The system has a unique solution, but this now is homogeneous. Thus, C1 equals C2 equals C3 equals 0. Sian dia. Kena salin balik. Saya padam. So, S is linearly independent. Then conclusion, S is a basis of V. Basis macam tu. So it is the same as for this and for this. Cuma panjang sikit lah, you write out this one is different, right? Macam yang tadi, ya. So you will put this and it's the same. Will be exactly like this. Okay. Panjangnya. Gitu. Alright, okay. Okay, kena tunjuk okay. Okay, exercise sikit jari tu. Okay, saya tengok sampai third page. Ada lagi yang tak berapa okay ni, mungkin sedang menyalin. Okay, any question before I go to the last part in 2 minutes? Okay, okay, okay. Okay, so I will change the question with changing this. Senang je sebenarnya nak buat soalan untuk dia tak jadi basis. This one, if I can write this or take this vector as a multiple of any of those two, multiple or combination, then it won't span and it is not linearly independent. Okay, that is how we create question. You don't know because sometimes you don't see the combination, right? So let's try, maybe it's not here, but let's try to add these two. 2, 3, 2. Yeah, so U3 is actually U1 plus U2. You can easily show it is not linearly independent if you realize that without writing all of this down. Tak nampak lah. Okay. Macam mana nak tulis ni? Saya tak nak padam ni. Alamak. Ya. Semua tak nak padam. Macam mana ni? Ni boleh lah. Okay, so I know if you can see it, U3 is U1 plus U2. Kalau nampak lah, kalau dia memang jelas kan. Sebab saya dah bagi tahu tadi kan. U3 is, if you rewrite this in terms of U1, U2, U3 equals 0, you will write U1 plus U2 minus U3 equal 0. Right? Nampak tak? Ni bawa ke sebelah. U1 plus U2 minus U3 equals 0. Right? So, ala pada pula. For linearly independent, if you have C1, U1 plus C2, U2 plus C3, U3 equals 0, you want to find C1, C2, C3, right? So in this case, C1 is 1. Kat sini kan, nampak tak 1 tu? Nampak? Mana ada nak nampak? But it's actually 1 times kan? Apalah you all ni? C2 is 1, C3 is negative 1. Right? It's equal to 0. But this is not all 0. Memang tak semua 0 pun. So from here, you can say S is not linearly independent. Habis cerita. Then it is not a basis. Kalau nampak. Kalau tak nampak, then you go back to the original definition, go through the process, show that you cannot find the C1, C2, C3 for spanning, or you show that this is not unique. Okay? In most cases, memang tak nampak. I'm just showing you, sometimes they give it not in terms of numbers, but you are given something. What if I give you this? Can you show that this is linearly dependent? Aduh, macam mana nak tunjuk ni, tak ada nombor. Then you can write, this is this plus this, right? So it's equal to 0. So C1, C2, C3. Okay, so now, okay, so 2, 3, 2. Ini cara tak nampak ya, ini cara orang tak nampak. Okay, then you do 2, 3, 2. Okay, and then you need to reduce. 1, 1, 1, 1, 2, 1, 2, 3, 2. Oh, if you find the tapi ni bahaya ya, this one. If you find that the determinant the determinant A is 0, okay, the determinant A is 0, then it might get many solution kan, not unique solution. So now confused. Macam mana nak kata sistem konsisten ke apa ke? But if you, ni siapa letak 0, 0, 0 ni? X, Y, Z. Okay, balik semula kepada first part. X, Y, Z. So if you do this, you will get something 0, 0, 0, blah, blah, blah. Okay, for you to fill in the blank. And then you will say that the system is inconsistent, right? Then it does not span. The spanning is just a plane. It spans by the only first 2 vectors. Because the first 3 the third vector is a linear combination of the first 2. So the first 2 give a plane, and the third one is on the plane because it's a linear combination, right? So you don't get 3 different vectors in one sense.